Hello everyone. Through this video we are going to discuss some sums on circular permutations. So here goes the first question. In question number 1, what is given? In how many ways? In how many ways can 6 men and 5 women seated here we should write be seated around a round table so that no two women are together. So coming to the solution part, let us first write down how many men and how many women are given. So here number of men we get as 6 and that of women we get as 5. So in total we are getting 6 men here, and these 6 men can be seated around the round table in actually the formula for circular permutation we are going to use here. These 6 men, actually out of these 6 persons, I am going to fix one of the person's position here in this circle. Means this is a circular arrangement. In this round table he has to sit. So let us first consider that this is the first man and his position is to be fixed anywhere at this table. So with respect to his position, remaining 5 persons, means when one person's position is fixed here, how many men are left? 5 men are left, and they are to be arranged in this way. In the remaining 5 positions they can be arranged. Let us consider this to be the second man, then this is the third one, this is the fourth one, this is the fifth one, and say this is the sixth one. So these 6 men can be seated around the round table in, we can write like this, 6 minus 1 factorial ways, and there it will be 5 factorial ways. After that, let us come to this condition that no two women are together. So it is very clear that we find these are the gaps in between 2 men. One first gap, second one, third one, fourth one, fifth one, sixth one. So among these 6 gaps, these 5 women are to be arranged so that no 2 women can sit together. So after this I am going to write, since no 2, or we can write no women can, just there is a correction, no 2 women, we should write like this, then the things will be more clear. No 2 women can sit together can sit together. Therefore, each woman is to be seated in the gaps, in the gap between two men. So we get here in total 6 gaps. Number of gaps is equal to 6, and in these 6 gaps we are to arrange 5 women. So in how many ways it is possible? Therefore, these 5 women can be arranged in how many ways? Of course, permutation we shall be using, means amongst these 6 gaps I'm going to use 5. So in P 5 ways we can do this. Therefore, required number of ways initially we had here these 5 factorial ways of arranging this 6 men in this circular at this circular table, and along with that at the same time we have to consider this arrangement, and there will be and in between. So where there is and, there is fundamental principle of multiplication. Therefore we can write here 5 factorial into P 5. So this can be arranged in the form, let us break it, 5 into 4 into 3 into 2 into 1 into. This can be broken into the form, split it into the form 6 factorial divided by 6 minus 5 factorial. So breaking this completely, we shall get 5 into 4 into 3 into 2 into, again breaking this part, we shall get 6 into 5 into 4 into 3 into 2 into 1. After complete multiplication, the result will come like this. The result is 86400, and this is the answer of this question. So questions involving circular permutation are of this kind and are to be solved in this way. Now let us come to another question. Here goes question number 2. This is question number 2. A round table conference is to be held among 20 delegates. Among 20 delegates, how many sitting arrangements are possible if two particular delegates are, here there are a few questions under this, always sit together. together. Then the next question is, here there will be question mark. Second question is never to sit together. Never to sit together. And then the third one is always separated. Always separated by exactly one person. By exactly one person. So let us come to the first question. Before coming to the first question, it is very clear that total number of persons is 20. So these 20 delegates are to be arranged in this at this circular table, so that they can sit comfortably. So how many such possible ways are there? Let us calculate that first. So in the solution part, here goes the solution. We find that total number of delegates is equal to 20. Therefore, around the table they can be seated. They can be seated. So what is the possible way? Of course, the formula to be used here is n minus 1 factorial ways, because we have to keep one person's position fixed. Therefore, following this formula, in place of n we need to put 20. So it will be 20 minus 1 factorial. The result will come as 19 factorial. So in 19 factorial ways. Then here we get the first question as always sit together. The two particular delegates are supposed to sit together always. So coming to the first question under this, so I'm going to write, actually when these two persons will be sitting together, they will always be considered as single person. So while writing the answer part, we shall write when two particular delegates sit together, they are to be considered as one person, or you can say single person, one person. So in this case, therefore the total number of persons become, so total number of persons will become, out of 20, 2 persons we are considering as single person, so it is of course 19. Total number of persons become 19. Therefore these 19 persons, the possible ways of arranging these 19 persons, possible arrangements will be, of course, 19 minus 1 factorial is equal to 18 factorial. But we consider these two particular delegates as single person, but they can interchange their places, means they can arrange themselves, arrange among themselves as 2 factorial ways. So again we shall write here, again the two persons can be arranged can be arranged among themselves, or we can say between themselves, between themselves in 2 factorial, that is actually equal to 2 ways. Therefore, by fundamental principle of multiplication, we need to consider both these two things, and we can write, therefore, total number of possible arrangements will be equal to 2 into 18 factorial. So this factorial notation will be there on 18 only. So 18 factorial. Now coming to the next question. The next question says what? Let us check what the next question was saying. These two particular delegates never to sit together. So in this case, what we shall do? Just we are going to subtract the total number of arrangements in which both the delegates sit together. Whatever result we are getting in the first case, that should be subtracted from this total number of arrangements, means 19 factorial. Okay, so here we are going to write in the second answer part. In the second case, we shall write what? When two particular delegates never sit together, then total number of arrangements is equal to, we can subtract, means from 19 factorial we can subtract the result that we got just above for two persons sitting together always. It will be 2 into 18 factorial. So here I get 19 into 18 factorial. Here in this case again 2 into 18 factorial. So from these two parts I can take common 18 factorial, and within the bracket 19 minus 2 will be there. So 18 factorial kept outside. So I get here 17 into 18 factorial is the answer for this second question. Again, coming to the third question, what do we get here? Let us check. The third question says what? Always separated by exactly 1 person. Means these two particular delegates should always be separated by exactly 1 person. So in this case, what we are going to do, just coming to this solution, number 3. So in this case, what happens? We are to fix the position of these two particular delegates, leaving exactly 1 gap between them. Then the remaining 20 minus 2 means total number of delegates were 20. So when we shall be fixing the position of these two particular delegates, in total how many positions left behind? Of course 20 minus 2 is equal to positions of 18 delegates left behind. So these 18 delegates can be arranged in 18 factorial ways, yes or no? Suppose this is the circular table. I wanted to fix positions of these two particular delegates, say P1, P2. Then in this part, in this entire part, and in this gap between these two persons, we are to fix, we are to arrange the remaining 18 delegates. Means total number of delegates was 20. Out of these, position of these two delegates we fixed, so that there is always a gap between these two persons. So how many delegates were left behind to be seated in this circular table? At this circular table, 18 numbers of delegates left behind. So in this particular part, including this gap, these 18 delegates can be arranged in 18 factorial ways. Yes or no? So the remaining delegates we can arrange in 18 factorial ways. Again, these two delegates whose positions were fixed can interchange their positions in 2 factorial ways, which we did in the previous question. But there should always be a gap between them. So in that case, what is the possible arrangement? Let us find it out. So I'm going to write here, when these two delegates are always separated by exactly one person, then we are to fix the positions of these two delegates it should be delegates. These two delegates at the table. So remaining number of delegates will be equal to 20 minus 2 equals to 18. Therefore, they can be seated in 18 factorial ways, as we have already kept the positions of two delegates fixed at the table with respect to their positions. The remaining delegates can be seated in 18 factorial ways. Then after, we have to come to the next part. Again, the two particular delegates can interchange their positions, or you can say their seats, in how many ways? Of course, 2 factorial ways. Means to the first person's place the second person can come, and to the second person's place the first person can go. So in 2 factorial ways they can be seated. So here in this case, total number of possible arrangements will be what? Both these two things, means 18 factorial ways and 2 factorial ways we have to consider. Therefore, total number of possible arrangements is equal to, we can write here, 2 factorial into 18 factorial. So ultimately it is 2 into 18 factorial. So this is the answer for the third part of this question. So this is how this type of questions can be solved. Then after, coming to another question, question number 3. So here goes question number 3. What do we get in how many ways? In how many ways can 4 men and 4 women be seated at a round table if the first question is no restriction is imposed. No restriction is imposed. Then the second question is each woman is to be between 2 men. And the third question is all women must sit together. All women must sit together. Means in each type of Roman 1, 2 and 3, in each case question is different, so ways of finding will also be different. So coming to the first question, no restriction is imposed here. So total number of persons will be, means in what way the men are to be arranged, in what way women are to be arranged, that is not nothing, no such condition is given. So directly we are going to consider the total number of persons as 4 plus 4 is equal to 8. So for circular permutation the formula is factorial n minus 1. So in place of n I am going to put 8 there and directly to get the result for the first question. So solution part. Here the first question, when no restriction is imposed. When no restriction is imposed. So in this case let us consider means total number of persons. Here total number of persons will be equal to 4 men plus 4 women is equal to 8. Therefore total number of permutations, circular arrangement, that means total number of permutations is equal to 8 minus 1 factorial, that is equal to 7 factorial. Let us split it up. After splitting we shall get 7 into 6 into 5 into 4 into 3 into 2 into 1, and the answer becomes 5040 ways. So this is the answer of the first question. Then coming to the second one. So in the second case each woman is to be between 2 men. That means each woman should be found in the gap between 2 men. So coming to the second question. Here goes the second question. When each woman is to be between 2 men. So in this case what we shall write? Four men can be seated at the round table in how many ways? Of course 4 minus 1 factorial ways. That means I shall be getting here 3 factorial ways, which will be equal to 6 ways. 6 ways. After this, it is given that each woman are to be between 2 men. Then it is very clear that each woman are to be seated in the gap between 2 men. Say these are the positions of the 4 men, M1, then M2, second man, then the third one, then the fourth one. So here we find these 4 gaps. There is only one way out in our hand, that each woman is to be arranged in between the gap between 2 persons, in the gap between 2 persons, 2 men. So here in this case we can write then 4 women can be seated in 4 gaps, in 4 factorial ways. Why so? Because the position of the men are already fixed. So with respect to their positions, these 4 women can be arranged, 4 women can be arranged in 4 factorial ways. So that will result into 4 into 3 into 2 into 1 ways. That will be equal to 24 ways. 24 ways. So both these 2 arrangements will have to be taken into consideration by fundamental principle of multiplication. So we shall be getting the required number of, therefore the required number of ways is equal to 6 into 24, and the result will come as 6 4 ja 24, 2 left, 6 2 ja 12 plus 2 144. This is the answer for the second question. Again, coming to the third part, in the third question we get what? All women must sit together. So all the women should be seated together. So of course we are going to consider here all the 4 women as a single person. So third part is when all women sit together. So under this question, what do we get? We consider all the 4 women as single person. Then total number of persons will be equal to, there are already 4 men, they are individually considered, plus these 4 women is considered as 1 person. So in total 5 persons which we shall be having. Therefore possible number of arrangements, possible means when they are to be arranged at this round table, possible number of arrangements will be, using the formula for circular permutation, it will be 5 minus 1 factorial is equal to 4 factorial, then it will become 4 into 3 into 2 into 1 is equal to 24 here. Again, although we had considered these 4 women as single person, again these 4 women amongst themselves can be arranged in 4 factorial ways. So that's what we are going to write next. Again, the 4 women can be arranged among themselves in 4 factorial ways. That will be equal to, actually these 4 factorial ways can be equated to 4 into 3 into 2 into 1 ways. That is equal to 24 ways. Therefore, total number of arrangements, means considering both the total number of arrangements, therefore total number of arrangements will be equal to, we have to multiply both these two things applying fundamental principle of multiplication. 24 by 24 will be equal to 576, and that is the answer for this question. Thank you.